Hi guys, so this video is going to be on applications of triangle similarity. So now that we have learned about dilations and we have learned about scale factor, now we're going to, also similar triangles and what it means to be similar, now we're going to use that information to find missing parts of triangles and also to work on some real world application problems, okay? So our first example here says, if in the figure CD is equal to 9, so that's this side here, so if this side is equal to 9, what is BE? So this is the side we're trying to find right here, BE. So if I know that these triangles are similar, and I do because we have this angle in common, and I've got these lines are parallel, which means this has to be the same angle here and here. So I know they're similar by angle, but now I can use that similarity to find x. So anytime I'm looking for a missing side, I'm always going to start by putting x on the top of my ratio, which means this triangle right here, the inside one, this one is going on top of my ratio that I'm going to set up. So I've got my x, which is the missing side, and I'm going to put it over the corresponding side in the bigger triangle, which will be my bottom triangle. So this bigger one is going to be the bottom triangle, and I'm going to put x over 9. Okay, so that's a ratio with those two sides. Then I have these other two sides here. This is 8 just from A to E, and then it is 4 more from E to D. So I'm going to be putting, if this is my top triangle, I'm going to be putting 8 on the top, and that corresponds with this other longer side that goes from A to D, but that would be 8 plus 4, which is 12. So x over 9 equals 8 over 12 is the ratio. And then in order to find out what x is, all I need to do is times both sides of this by 9. So I'm going to grab my calculator here, and I'm just going to put in 8 divided by 12, hit enter, and then times it by 9, and I'm going to get 6. Okay, so x equals 6. It doesn't matter which order I do here. I could have done 8 times 9 and then divide by 12, or 8 divided by 12 times 9. Either way, I get 6. Okay, so let's try another one. Let's see, this thing is in my way. There we go. Okay, so now I have two triangles. The triangles are similar, so that's given to us. We know they're similar. So it's saying if side AB, so that's this one, AB, if that is 10, we need to find EF. So we're looking for this side right here. So again, because x is in this triangle, that's going to be my top triangle, because I want to keep x on the top of my ratio, over 10, because that's the side that corresponds, right, equals, and then I have 3 and 5, so 3 comes from my top triangle, 5 from my bottom, and now I'm just going to multiply both sides by 10 to get x by itself. So x equals 30 divided by 5, or if I could reduce this first to 2 times 3. 3/5 times 10 is 6. Alright, so let's try this one. The shadow of a man 6 feet tall is 30 inches long. Okay, so let's draw a little picture. If I have a man here who is 6 feet tall, the shadow that he casts is 30 inches. At the same time of day, a building, so here's my building, and it casts a shadow of 125 inches. How tall is the building? So we can use our similar triangles here because this angle right here would be a right angle, so the building to the ground or a person standing to the ground is going to have a 90-degree angle. And this angle right here is going to be the angle that the sun is hitting the building. So those two angles will be the same. So these are similar triangles. I'm looking for the height of the building. So because x is in my bigger triangle, this is going to be the one on the top, and this one's going to be the one on the bottom. So x corresponds with 6. So x over 6 would have to equal 125 over 30. So just go ahead and multiply both sides by 6. So 125 times 6 divided by 30, or you could also do 125 divided by 30 times 6. Both are the same, and x equals 25. Oops, I just realized I messed up. So the building is 25, but I used, let's see, this man was 6 feet tall, and the shadow was 30 inches, and this was also in inches. So we need to convert to inches or to feet. To find the height of a building, feet makes more sense. So I would want to turn these into feet by dividing them by 12 before I started. So let's do that. So 30 divided by 12 is 2.5. So this side is 2.5 feet. And 125 divided by 12 is 10.4 feet. So let's do this in feet instead of inches and feet. So x over 6 equals 10.4 over 2.5. So let's do that. We're going to times by 6, right? 10.4 divided by 2.5 is 4.16. Times that by 6, and we have 24.96. Well, look at that, which rounds up to 25. So either way, we still got 25. So 25 feet is the height of the building. So that would be B. Okay, let's do the next one. All right. A lens is placed 16 centimeters away from an 8 centimeter object. So here's the lens. Here's the distance between the object and the lens, and here's the height of the object. An image formed 12 centimeters away from the lens. How tall is the image? So our picture here is kind of hidden. So we're looking for this height here, this x. So we're going to take x on the top. That's going to be our top triangle. Will be on the top, and this will be the bottom. So x corresponds to 8. That should equal 12 over 16. So just multiply both sides by 8. So 8 over 16 would reduce to 1/2. So x equals 6 centimeters. Okay. Whoops. Thought I skipped ahead. Okay, let's try this one. All right, given the following figure, what is the value of x? So we're looking for the side length that goes from here to here. Okay. We know that they're similar because these lines are parallel, which means these angles are the same, and we know that that angle is the same. So x corresponds to this larger side, 12, the same way that 6 corresponds to this larger size, which would be 6 plus 10, or 16. So to get x, all we have to do is multiply both sides by 12. X equals 6 times 12 over 16, which is 4.5, which would be the same as D, right? All right, let's just do one or two more, and then we can, I think we've done enough examples. This one's very similar to the previous one. Okay, here we have find the missing value. So we're looking for the distance across this river. So that's x. Our smaller triangle is up here, so that will be on the top. So x over 32. Now, it looks like this side, this is only 32 from here to here. So that means the bottom is going to be x plus 32, actually. And that is going to equal 60 over 80. Okay, so because I have x in the bottom here, x plus 32, I've got to get it out of the bottom. So I'm going to multiply both sides by x plus 32, so those will cancel. That gives me x equals 60x. Now I'm multiplying 60 into the parentheses. And 60 times 32, let's see, 60 times 32 is 1920, all divided by 80. So now I'm trying to get x alone. I have one over here and one over here. Before I can access this one, I've got to get rid of this divided by 80. So I'm going to multiply both sides by 80. So that gives me 80x equals 60x plus 1920. Now I can subtract 60x from both sides, and I've got 20x equals 1920. And then divide both sides by 20. 1920 divided by 20 is equal to 96. So this side right here would be 96 meters. Okay, go ahead and give some of those application problems a try, and we will see you next time.